Hey guys, so in today's episode, we're going to solve the problem diameter of a binary tree. Okay, so it's an easy problem on Leetcode. So the question says, given the root of a binary tree, return the length of the diameter of the tree. The diameter of a binary tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. The length of the path between any two nodes is represented by the number of edges between them. Okay, so yeah, let's take this example. We have 1, 2, 4, 5 and 3, right? So we need to find the diameter of the tree. And what the question says is that it can pass through the root, or it's not important that it should pass through the root. Okay, we just need to find the longest path between any two nodes in a tree. Okay, so if you look at this example, the output is 3, and the way we can solve it is by going from 4 to 1 and 3, and otherwise you can go from 5 to 1 and 3. So basically 3 is the diameter of the tree as we go, from 5 to 3. So 1, 2, 3. Right. So I'll explain it to you guys through an example. One more example, like if this is one example, it could be there. But what also could be there is, something like this. So we have 1, let's say 2 here, then 3. Right. Now we can also have like 4, 5, 6 and 7, something like this. And when you have something like this in your question, the diameter of the tree will easily be something like 5, 4, 3, 6 and 7. So it would have like 1, 2, 3, 4, 4 nodes in the tree, and that would be the diameter of the tree. So 1, 2, 3, 4. So it can also be from 7 to or from 5 to 2, but this could also be one of the diameters of the tree. It doesn't always have to pass through the root. It can also be, it just has to find the longest path between any two nodes in the tree, right? So this is also the method this is also a way in which it can happen. But in this case, we're passing through the root. So the diameter is 4 to 1 or 3, 4 to 1, 3 or 5 to 1, 3. So now how to find the diameter? So how we'll code this is, we'll actually keep a pointer over here called PTR. Right, PTR is equal to 0. And what we'll do is, we'll start from the root node, right? So we'll check if the root node is present or not. And if it is present, we'll go to the left node of the tree. So it is present, we'll go to the left node. It is again present, we'll go to the right node. Right, left node, sorry, and we'll reach 4. Now when we reach the leftmost node of the tree, what we'll do is we'll check if its left is none and right is none. So if its left and right are none, so 4 has 0, it will return a 0 and 0 if its left node is none. And then we'll check the right node, and if the right node is none, we'll also return 0. Right. So in this problem, what we'll do, we're keeping a pointer over here, right? So what we'll do is we'll check if the left and right of the current node, so over here in this case 0 and 0, so L plus R is greater than PTR or not. So if L plus R is greater than PTR, which means so what PTR is basically the maximum diameter of the tree, right? We're keeping a maximum diameter of the tree named PTR. So if 0 plus 0, if this L plus R is greater than PTR, we'll just change that with the PTR. If L plus R is greater than PTR, we'll just make PTR equal to L plus R. Okay, but if it's not equal to that, but if it's not greater than that or not, if it's not greater, basically what we'll do, it will just return 1 plus max of L and R. So whatever is the max between L and R, we'll just return it to 4 and adding that with a 1. Okay, so over here, in this case, we have 0 and 0. So what we return is 1 plus max. What we return is 1 plus max of L and R, L comma R, one of them. Right. So when we do this, the max is 0 if we take L or R, and we just return a 1. Right. Now why we do this is return 1 plus L comma R is basically we need to find the maximum height of that node, maximum diameter of the node, or sorry, the maximum height of that node. So in this case, 4 has the highest height of 1, right? Because it only has one node, which is 4. And when we return a 0, we have nothing. So we have to return +1 to it, so that we have at least, so that it gets its actual value of nodes present in the diameter of it. So it has only 1. So 1 would be present over here. And why we take max of L comma R? So let's suppose we have over here 6 and 7, right? Now from left side of 3 we would have returned a 0, but from right side of 3 we would have returned a 2. I think a 2, yeah. So this would have returned a 1, so this would have returned a 1, this would have returned a 2, and this would have been a 3. Okay, so 3 would have been returned from this side. So 0 and 3. So why we take the max of it is because, because 3 has the maximum diameter of 3, and we need the maximum of it, and we need to add 1 to it to pass it on to 1. Okay. So yeah, let's continue. So here we have 1 as the height. Right, now we go to the rightmost side of the tree, which is 5. Now when we go to 5, again we have a 0 and 0 over here. Its left and right nodes are none. So return a 0 and 0, and we return 1 plus max of L comma R to it. We'll first check if L plus R is greater than PTR or not. And if it's not, we'll just return a 1 plus max of L comma R. Okay. Now when that's done, where's the mouse? Yeah, when that's done, now what we'll do is we'll again check if L, which is 1 right now, and R, which is 1 again, if 1 plus 1 is greater than PTR or not. And it is greater than PTR. So 2 is greater than PTR, so we'll just change this to 2, and we'll return 1 plus max of L comma R to 2. So what is 1 plus max of L comma R? It's 2. So 1 plus 1, it's going to be 2. So we return a 2 over here. Now we go to the rightmost side of this node, which is 3. Right, when we go over here, we get a 0, and this would have returned a 1. Okay, now we have to check if 2 plus 1 is greater than 2 or not. So 3 is greater than 2, so the PTR will become 3, and PTR becomes 3, and we return the max, 1 plus max of L comma R. So the max is 2, which is from the left side we get, and we just return a 3 to this point, and in the end we just return PTR equal to 3 as the output. So this is the diameter of the maximum diameter of the tree. So this is for one example. Let's take another example. Suppose we have something like this. Right. The same thing happens. The first thing we'll do is go to the leftmost node, which is over here. Right. A 0 and 0 would be returned from its left and right nodes, and a 1 would be passed on, doing 1 plus max of L comma R. We'll keep a pointer check, which is equal to 0 right now, right, which will give us a maximum diameter. So this is 0. Okay, so yeah, so now what we'll do, we returned a 1 from this side, right? Now we'll go to 2's rightmost node, which is 4, right? And then we'll go to its leftmost node, which is 5, and then it's 0 and 0, and we'll return a 1 over here, right? Now we'll first check if L plus R is greater than PTR or not. So it isn't. So we'll just return 1 plus max of L comma R, which is 1. Now we'll go to the rightmost node of this node. We'll go to 6, we'll go to 7, we'll go to 8, and we'll go to 9. So a 1 is returned in this side from all of them, 6, 7, 8, and 9. Okay. Now when we reach 9 over here, a 0 is returned actually. Sorry. 0 is returned from its all their left sides. Now when we reach 9, we again get a 0 from right side, and we return a 1 to it. Now when we return this to 8, what we get from the right side is a 1 returning. So what we get is 1 return. So as we are getting a returned output of 1, what we'll do is we'll add a 1 to it and then return it. So 2 would be returned, 1 plus max of L comma R. So L is 0 and R is 1. So what is returned is 1 plus 1 is 2. Similarly, 3 is returned over here, 4 is returned over here, and again what we'll check, and as we do it, we'll keep on incrementing the pointer to the maximum, whatever the maximum height diameter is. So right now it's 4. Now we'll check 1 plus 4 is 5. Right, now since 5 is greater, we'll make this PTR equal to 5, and we'll make this equal to 1 plus max of L comma R. So what is 1 plus 4? It will be the output, and that would be 5 would be returned over here. Now we'll check 1 over here plus 5 for 2. Now when we do that, we get an output of 6, and 6 would be returned over here, doing 1 plus max of L comma R. So 1 plus 5 is 6. Now we'll go to 10. Once right side, which is 10, we'll do a 0, 0. We'll get a 1 over here. We'll return a 1, and now we'll just check if 1 plus 6, what will 1 plus 6 give us is 7. So 7 is the maximum diameter of the tree, right? And we'll just return 1 plus max of L comma R, which is 7 over here. And in the end, we'll just return the PTR equal to 7. Equal to 7 as the output. Okay, so this is how we'll solve the problem, guys. Let's just code it out now. Okay, so to code this out, let's do it. Okay, so what we'll do is first we'll make a pointer variable equal to 0. Right, then we'll make version root. We're basically just doing an in-order traversal of it. If not root, return 0. Right, now if it's not root, return 0. Else, then L is equal to recursion of root.left, and R is equal to recursion of root.right. Okay, now we'll check if L plus R is greater than self.ptr, and if it is, then what we'll do is we'll make self.ptr equal to L plus R. So L plus R, and in the end we'll just return 1 plus max of L comma R. Okay, and we have to call the function here recursion root, and we'll just return self.ptr as the output. So let's run the code. Yeah, and submitting it. Yeah, it's submitted, guys. Okay guys, I think that's all for today's video, and if you like the video, please do like, share and subscribe, and I'll see you guys in the next video. Thanks.